So far everything is going smoothly. We always use law of sines when you have a side length across from an angle. We're using this to find and solve for any missing measurement in any sort of triangle, not necessarily a right triangle. Now, this is where it all kind of goes wrong, something called the ambiguous case. If something is ambiguous, that means it's not clearly stated, it's open to interpretation. And you'll think back to geometry that there was no ASS property of congruence for triangles. The ASS property does not exist because there could be no possible triangle with the given information, or only one or more than one. And if there's more than one, then you can't say two triangles are congruent. This box right here does a nice job to explain what we are looking for and how to check. Just so you know, if I find any angle and take the sine of that angle, let's do the sine of 42 degrees, and I hit enter, that gives me this ratio. And what is the supplement of 42? That's 138. If I take the sine of 138 degrees, what you'll notice is I get the same ratio of opposite and hypotenuse. That an angle in first quadrant has an angle in second quadrant that has the same y coordinate. That's why there's an ambiguous case, because there could be two angles that have the same ratio. So here's what we're going to do to decide how to check if a second triangle is possible. Once you find the first angle when you solve, you want to take its supplement. If the sum of the supplement and the given angle, the one that was provided in the original setup, is less than 180 degrees, then you could make a second triangle, and then you would have to do two setups. There's an easier way, I'll tell you, and I will explain this when the time comes. This is a very descriptive 3 letters, and I'll explain it again later. So here's what we're going to do. We're going to draw a picture for example 3. I'll draw a triangle. I need an obtuse angle, about 115 degrees. We'll make that side, or that angle A of 115 degrees. Side length A, little a, is right here across from it. And B, it doesn't matter where you put the B. I'll put it here. We don't know the angle. We do know its side length. So here's classic law of sines we're going to use because we have a side opposite an angle. And first we're going to find an angle, take its supplement, and then see if the supplement, they call it the new angle, just know that this means supplement. If the new angle and 115 degrees add together to be less than 180, we have two triangles. Alright, here goes. Let's first set this up. Sine 115 degrees divided by 20 is equal to the sine of B divided by 11. Because we're looking for an angle, I need to use an inverse. First, we'll do multiply these together. 11 sine 115, close the parenthesis, divided by 20. This gives me the sine of angle B. I now want to sine inverse this information. Take the answer by hitting second and the negative sign, and I get 29. So let's call this B. Angle B is approximately 29.899 degrees. So I next want to take the supplement of B and determine if it's possible. What is 180 minus this answer? 180 minus this answer was 150.101 degrees. If I take the supplement and the original angle, add them together, is it less than 180? The answer is no. It's not less than 180. So only one triangle is possible. The reason I know this is when you look at S, S, and A, the S, S, and A, in this instance, the way I drew it, looks like it's counterclockwise. The large side, then the small side, and the angle is the order. Back to this where I wrote this trick. This is descriptive by saying the little s, then the long s, and then the angle. If the short side is the side that's across from the angle, there might be, and there should be, more than one triangle possible. What I still need to do is still need to finish this. We have 29.899 approximately degrees. What I'm going to do is, let's get that answer back. And I get sine inverse that one. Okay, if I add this angle into 115 and I subtract it from 180, or really I take 180 and subtract that sum from there, that gives me what I didn't even label as angle C. Angle C is approximately 35.101 degrees. So we know angle B, we know angle C, we were given angle A, that takes care of the angles. Next we need to find side length C, little c, lowercase c. So we'll do the sine of 35.101, that number is still in my calculator, as exact as it can be, divided by little c, and then I'm again using A because A was the given pair, and we're going to cross multiply and solve for C. 20, what is 20? Times the sine of this exact full angle, second answer. Then I'm going to divide it by the sine of 115. This will approximate my value for the side length. So little c is approximately 12.689 units, which makes a lot of sense that 12.689 is the side length. It makes sense because it's the middle angle, and this should be the middle side. The smallest side is always across from the smallest angle, the middle side is always across from the middle angle, and the longest side is across from the longest angle. Alright, so exercise 4 will teach us a little bit more. What we're going to do is still draw another picture. I have angle C is 40 degrees, so I'm going to draw a 40-degree angle somewhere down here. We'll call that C. We have side length C, which is 13 units, and A. Let's see, A is 16. So I could put 16 here, I could put 16 there, I'll just put it right here. Let's see, if this is side A, then I'll put angle A here and B there. Alright, so which way is my two sides of my angle, which way are they oriented? Side, side, angle, angle, side, side. So here's what we're going to do. Small side, long side, angle. This is what I talked about earlier. I believe this is the ambiguous case, and there may be two different solutions. We're going to solve this one first, and I'm able to recognize it because I understand what this means. So first, what I'm going to do is do the sine of 40 degrees, sine of C divided by C, side length C is 13, and we're going to solve for angle A, sine of A divided by 16. Multiply, divide, and then we're going to sine inverse. We can kind of do that in one step, but I don't know. I get worried, make a mistake. So okay, so multiply this and divide. This gives us the value for the sine of A. I next want to sine inverse this, and this approximately tells us the value of angle A. I'm going to call this A sub 1. A sub 1 is approximately 52.290 degrees. Its supplement we're going to call A sub 2. And we're going to find that a little bit later when I explain that better. So let's see, this would be 52 degrees, 0.290, which leaves us angle B. I'm going to add 40, the given angle, and the first value for angle A. I'm going to subtract the sum from 180. Angle B is approximately 87.709 degrees. Okay. 87.709. I'm going to use this exact answer, not the rounded one, to find side length for B. So I still want to use my given pair. My given pair was sine 40 degrees divided by 13 is equal to the sine of this answer, the 87.709, divided by little b. Cross multiply and divide. So let's do 13 sine, and I'm going to use the answer, the full answer, not anything rounded, and divide it by the sine of 40. This approximately tells you that side length is 20.208. So the value for little b, lowercase b, is approximately 20.208 units. Alright, so let's go across here. Let's rewind it back. Let's see, so 16 sine 40 divided by 13. Oops. Went one too many. Alright, it's quicker just type it out, isn't it? 16 sine 40 divided by 13 and I'm going to sine inverse this, and this should get me the same answer that I got before. If I didn't get the same answer, there'd be a problem. All right, let's take the supplement of this minus the exact answer. Okay, the second possibility is angle A is 127.709 degrees. Take the supplement, add it to the known angle that was given to us. Add these together, plus 40. Since this is less than 180 degrees, I know that there's a second possibility for a picture for the triangle. I'm going to start by drawing the same 40-degree angle I did before, 16 as a side length. Instead of drawing side length C this way, I can imagine that B is a pivot point. And if I rotate this angle, if I rotate this side on this pivot point, it has a potential of swinging inwards. It could be the same length as before, but pivot inwards. And this will create our second triangle. Here was the first one. If I rotate this and that, this side and that side would be of the same length. If I put it straight down, it will go beyond this base angle, and I can't adjust this angle. That angle is fixed. But what this tells me is this. If 52 degrees, I'll put this, was the original value for A1, then this angle would also be 52 degrees as well. And on the other side of this linear pair would be its supplement. That's what we're doing with the supplement when we take the supplement. This is a little bit confusing, so I'm going to simplify our picture. What I'm going to do is side C, 13, small side, long side, and angle. So I'm going to take the supplement and call this A sub 2. I can't draw it in the picture, I don't have enough space. But now what I'm going to do is find the value of angle B. So I want it to be exact, so we're going to do it the exact way. Here we go. And then we're going to take its supplement, so 180 minus, I like this exactness, Math is one of those subjects where you want it as exact as possible. So take the supplement and the original angle, add that together, which I now realize I had on my calculator to begin with. I didn't need to waste those precious seconds. That means the second potential value for angle B would be 12.291, which makes sense because this is like a tiny sliver of an angle. We're going to use that to find side length B. The other potential side length for side length B, we'll do sine of 40 over 13 equals the sine of this answer divided by little b. And this will kind of wrap up our ambiguous case, which happens when we have a small side. Oh, actually I want the full answer. 13 sine. There we go, that's better. That happens when we have the small side, the large side, and the angle, which means that this side length could also be 4.305 units. In the case of an ambiguous case, you must do both setups and find and solve both triangles. Again, this occurs, to summarize, this occurs when you have small side, long side, and angle. That happens when the small side pivots in and creates a second triangle. And we would use the supplement of the angle to be and represent the second potential value for that angle. All right, moving on to our next and maybe final video.